Welcome to Week 2, Ecological Economics and Conservation. Biosphere 2 was a lesson in humility. It was a $200 million facility designed to be a self-sustaining life support system. 3.2 acres were enclosed. It was an experiment in sustainability and complex systems. 8 scientists sealed into it for 2 years. What happened? The oxygen levels dropped due to the unset concrete. Additional oxygen had to be pumped in. CO2 levels became dangerously high. Nutrient cycling didn't work effectively. Tropical birds died after the first freeze. 19 of 25 small mammals became extinct. The facility was overrun by Arizona ants, which killed off introduced insects, and insect pollination stopped. The cost was $200 million for 8 people in over 2 years. $12 million per person annually failed to do what the Earth does for free. Our world problems are interconnected. Think about all of these different things and how they work together or don't work together. Economics strongly influences political considerations for the entire constellation of interconnected world problems. The father of modern economics was Adam Smith, and his publication in 1776, An Inquiry into the Nature and Causes of the Wealth of Nations. Human motives are often driven by self-interest, but competition in the free market would tend to keep prices low, yet create incentives for a wide variety of goods and services. It is not from the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own selfish interest. The free market appears chaotic and unrestrained, but selfish interests may help guide it by their collective invisible hand to supply the right amount and variety of goods and services to meet demand. Garrett Hardin, the author of The Tragedy of the Commons, in Science in 1968, contended that the commons was used as a metaphor for the earth and its growing human population. It bleakly stated the future of the planet if human population remains unchecked and the commons continue to be degraded. Multiple individuals acting in their own self-interest can destroy a shared resource, that is, the commons. Individual herders or people collectively place more footprints on the commons or earth than can be supported. The average single-family house completed in 2006 had 2,469 square feet, 769 more square feet than in 1976. The average rates at which people consume resources like oil and metals and produce waste like plastics and greenhouse gases are about 32 times higher in North America, Western Europe, Japan, and Australia than they are in the developing world. So here are some of the values in $1 trillion in the United States of soil formation, recreation, nutrient cycling, water regulation and supply, and other services. So the total value of these services is $33.3 trillion US as of 1997. The planet provides many goods and services for free. If we were to do it, again, $33 trillion, and nearly all of this is outside of our current market system. The global GDP in 1997 was $18 trillion. So you can certainly see the value of goods and services that are free. Also, pets can have large ecological prints. Instead of footprints, it says paw prints. Calculated ecological paw print of a medium-sized dog is more than twice the ecological tread print of an SUV. The steady-state economics model. With respect to matter, the economy is an open subsystem of a closed finite total system, the biosphere. Matter cycles within and energy flows through the global ecosystem. There is no escape, however, from the law of thermodynamics. In other words, the first law of thermodynamics equals the conservation of energy. Modern humanity arose about 10,000 years ago with the invention of villages and political hierarchies. The economic history that followed can be summarized very succinctly as follows. People used every means they could devise to convert the resources of Earth into wealth. The distinction between growth and development. Could there be development without growth? Can there be growth without development? Sustainability is the amount of consumption that can be sustained indefinitely without degrading our capital stocks, including natural capital. Sustainability, the amount of consumption that can be sustained indefinitely without degrading capital stocks. So this graph shows you on one axis the short-term consumption rate versus the capital stocks on the other axis, and the trade-off between those two. So where is the line between what's sustainable and what's unsustainable? I'm not sure we know that yet. So in a parallel to that is the life history evolution of an organism, which has on one axis trait A, the life history, reproductive output, and on the other axis, life history trait B, which is future survival. So the salmon, for example, king salmon has thousands of offspring in one reproductive session, bout. The blue whale has one every 2 to 3 years, an 80-year lifespan similar to human. So if we were to consume salmon, where would the sustainable population be? Or if we were going to take whales, what is sustainable and what is not? Cost-benefit analysis seems to be simple. If costs are greater than benefits, the project should not proceed. If costs are less than benefits, the project should proceed. However, it must convert all costs and benefits in the same currency. It must consider all the trade-offs, both instrumental and intrinsic value, hidden costs, and externalities. An externality is a true cost in terms of environmental degradation, resulting from an economic transaction that is not included as a debit against economic returns. Willingness to pay. How much would you be willing to pay to protect blue whales? How much do people pay to see blue whales? That would be a travel cost method. Present value and discounting method would be how many would you rather receive, $100 today or the equivalent of $100 in a year's time? Costs and benefits often change over time. The general preference to receive good things now and put off bad things until later is called time preference. Many economists advocate converting all future costs and benefits to present value. Future sums of money are discounted by a rate that reflects time preference. Environmental impact assessment is the process of identifying the potential impacts of a project or policy before it goes into effect. This is required of federal projects in the United States since the National Environmental Policy Act was enacted in 1970. That includes federally funded projects as well as projects undertaken by the federal government. Risk assessment and management. Risk is the probability of a given potential hazard causing a given consequence, multiplied by the magnitude or severity of that consequence. The precautionary principle. Since not all possible negative consequences of a project can be known ahead of time, this ethical principle states that if the consequences are judged by some informed persons to have a high likelihood of being negative, it is better to abandon the project. Here are some economic terms: consumptive use value, productive value, amenity value, existence value, intrinsic value, beneficiary or bequest value, non-consumptive use value. For the forum this week, you will choose one of these terms and find an article to present on its application. Here are some environmental economics resources you might find of value.